Hello students, welcome back into the another session of CS07 data structure using programming in C. As we are discussing about unit number 2, sorting and searching, and lastly we have completed with bubble sort. Now we are going to start another type of sorting technique, that is insertion sort. As indicated into the previous lecture, in all the topics of unit number 2 we'll go with three different parts, that is theory, algorithm, and then we'll go for program. So let's start with the theoretical session of insertion sort. The theoretical session of insertion sort says that insertion sort is also known as iterative sorting algorithm or iterative sorting technique. In this particular algorithm, the first element is sorted with respect to itself. That means from the entire list of numbers, this algorithm automatically selects the smallest value if it is from small to large, and even from large to small it selects the highest value, and then comparing the other value with this, it sorts the number available into the one-dimensional array. Again I am repeating my words. Insertion sort is also known as iterative sorting technique, iterative sorting algorithm technique. In this particular sorting technique, this algorithm automatically selects the first element as a sorted element, and then by comparing the other value with this first sorted value, it rearrange all the numbers are known as insertion sort. That means in insertion sort, it inserts the smallest value at a particular position from the lowest to highest. That is called as insertion sort. So let's see the theory in detail. Insertion sort is also known as iterative sort algorithm. When using this algorithm, the first element is sorted with respect to itself. The algorithm then takes the second element and compare with the first, inserting it in front of the first one if necessary. From this point forwards, the algorithm takes the next unsorted element and compare with the sorted element, insert the element in correct position as needed. The algorithm continues in this manner, shifting the sorted element as needed to make room for the next element to be sorted. Now suppose we want to plot this particular theory in terms of example, then we can take like this. Suppose we have a values like this. Say for example, right now I have 5 values like 5, 3, 0, 9 and 8. This algorithm first find out the smallest value and put it into the first position. Then after shifting the smallest value at first position, it compares all the others value with this particular number. Say for example, if it starts with 5, then 5 is greater than 0, it put 5 onto the next position. Then 3 is smallest than 5 and highest than 0, then it replaces this 5 with 3 and put 5 onto the position of 0. Then it compares 9 with 3 as well as 5. As 9 is higher than this 3, it put onto next position, but on next position it already have the value called 5, so it compare 9 with 5. 9 is highest than 5, so it put onto the next location, and that 8 remains as it is. Then after 8 is compared with 0, it is higher than 0, higher than 3, higher than 5, lowest than 9. So what it does, it replaces 8 and 9. And ultimately, whenever the last value becomes the highest one from the entire list, you will see that the entire list of number is sorted. So this technique is known as insertion sort. So let's see how can we put it into the logical manner by using the algorithm. Algorithm for the same is like this, where there is a first step called the initialization step. Into the initialization step, it initializes the two variable, that is L of 0 is equals to 0 and n is equals to number of elements. So L represents the list, and this into the entire list it represents the number using the variable called n. That means L represents the entire list, and into the list n represents the individual number. Now in step number 2, it represents our looping control structure, which repeats the next step called step number 3 to step number 5 for all the values of the entire list. That means starting from the 0th position to the previous position, step number 3 and step number 4 gets repeated. During this repetition of the step number 3 says that if a smallest value from the entire list is founded, it replaces with the temp, and one pointer is set to the first position of the entire list, and it moves every time whenever the looping control structure is repeated. So for comparing and repeating value with pointer, step number 4 works. In that you can see that there is a one decision making statement where the value of temp is compared with all the list value, and if the value is founded to be smaller than the first value which stores inside the temp, it replaces the value, and every time that is managed by one internal pointer. So I have written pointer is equals to pointer minus 1. During the comparison, if any of the value is founded to be smaller than the first value, it replaces that particular value with the pointer location, and finally the algorithm gets completed. So in this 6th step, insertion sorting will work. So let's see how can we implement this particular program through programming in C. So for that, program is written over here. No doubt in this program we haven't used the concept of pointer. By using just a one-dimensional array, we have implemented the program. So the definition would be like this: write a program to implement insertion sort using one-dimensional array. Into the starting of the program, after the declaration of two necessary library functions, here I have declared the global variable. If you remember, then we have discussed about one topic called storage class in previous chapter. In storage class, four types of storage classes are there: local, global, static and register. From all this, here we have introduced the concept of global variable declaration. So two global variables are declared, that is I and k. Then the two functions I have taken, where function number 1 is insertion underscore sort, and the type is function with argument without return value. Function number 2 is display, even it contains the type called function with argument without return value. First we'll discuss about this prototype. So we can write that this is prototype 1, and this is prototype number 2. So let's discuss about prototype number 1 first. In prototype number 1, as a parametric value, the data types are integer, pointer, and integer without pointer. As this function is without return value, so I have declared void over here. Same like that in display. Integer remains same with pointer, and normal integer remains as it is. So this particular function only sorts the value. So here we can mention that only sort the value. And this display function print sorted value onto the screen. So first, into the void main statement, we can keep this particular portion up because generally we are managing in this way. So I'm just shifting over here. So first I have written void main. Into the void main statement, there is a declaration of one variable called a number is equals to 5. As far as the algorithm is concerned, this is a list, and this particular list represents that it will accept any 5 numbers, Then there is a one array called a list. It contains the size called 100 and one more local variable I. We'll see that what is the purpose of all these numbers. Then there is a message enter any 5 numbers. So whenever this program get executed, you will find a one message onto the screen which indicates that we have to enter any 5 numbers. For accepting the numbers, there is a loop called for I is equals to 1, I less than equals to number I plus plus. That means this particular loop will repeat 1 to 5 times. As this number contains 5, so ultimately 5 will come over here, and this loop repeats 1 to 5 times, and it stores different 5 values into the array called list. So all the 5 values are stored in this particular list. Obviously this list starts with 0 as it is an array. So here we can write that this is actually a one-dimensional array. Now after that there is a one /n and one message is there. Stepwise result is as follows: insertion underscore sort list all the numbers and number which is ultimately 5. So this particular function will perform its functionality on the list of array which contains any 5 number, and then it will display. So right now we'll not discuss about this display. First we will complete about the function called insertion sort. Say for example over here, suppose we have inserted any 5 numbers. So that 5 numbers came into the dummy argument called L of array. Whatever the 5 numbers I have entered will came in this L of array, and number called 5 came into this particular n. Then the actual implementation of algorithm starts from this particular line. So here I have declared the 2 variable called pointer and temp, and L of 0 is equals to -0. Here I have declared L of 0 is equals to -0 because whenever the pointer get increment, it sets to the first position. So for that there is a one loop for I is equals to 1, I less than equals to n, I plus plus. That means it repeats 1 to 5 times, and during every repetition it sets the pointer value at I minus 1 position. whatever the position is set by the particular pointer takes the value and stored inside the variable called temp. Then step number 3 and 4 according to algorithm works over here, where while temp is less than L of pointer, L of pointer plus 1 is equals to L of pointer, pointer minus minus, which stores the second value which is highest than the previous one. For exchanging the values, L of pointer plus 1 is equals to temp work, and it is represented by one step. That particular steps store the smallest value and periodically highest value onto the next position using this particular for loop. After the completion of this insertion sort UDF, all the number gets sorted and stored inside the one-dimensional array called list. So display will work. Display again transfer all that sorted value and the number into the L of array and n, and then there is a message. Sorted list is as follows. Loop repeats from 1 to n time, and simply it prints all the sorted value onto the screen. Now let's see this particular program over the Turbo C for better visibility. So for that, let me first transfer this particular program over the Turbo C. Open Turbo C. Search for the file called 2.c. The program that we have written is over here. Let me remove all this commented section that we have done into the text file. Just removing all this commented section. Save this particular file. One more line is there, let me remove that also. Let's execute. As there are no syntactical errors, enter any 5 numbers. Suppose I am entering 9, 6, 1, 0, 1, 2, 3, 4, and last one is 2. So number gets sorted and it will print as a 0, 1, 2, 6 and 9. Let me rerun again, but before that let's put one basic function called CLRS here. Again enter the number for second time, 9, 6, 1, 0, 2. Press Alt F5. You will see that on a step number 1 it has sorted the numbers like this: 1096, 102, then so on, and lastly we'll get a sorted value, that is 0, 1, 2, 6 and 9. That is from smallest to highest. Let's see this particular program by debugging the code. First, try to focus over here. Number is equals to 5. This loop repeats from 1 to 5. Every time it accepts the number. Say for example, suppose I have entered 9, so it stores on list of 0, then 3 on list A of 1, then on second position 1, on third position 4, and on last position 2. So what the situation is, list of 0 is 9, list of 1 is 3, list of 2 is 1, list of 2 is 4, and list of 5 is equals to 2, up to this particular program. Then there is a one /n, and the message is stepwise result is as follows. Then there is a call, a function call of insertion underscore sort, and it passes all these unsorted value called 9, 3, 1, 4 and 2 into the insertion sort, and 5 into this n. Then as per the algorithm, it takes one by one all the values. First it will set the smallest value from the entire list onto the first position and compares all other value with the same. It sorts the number. Once the sorting is done, the program get exit from insertion sort, and the next function call is done, that is called as display. This display contains the list of array and total number where all the numbers are sorted. So this for loop print all the sorted numbers starting with 0. As per the list, smallest number is 1. So 1, then 2, then 3, then 4, and last is 9. So it has sorted all the numbers and displays onto the screen. So I hope all of you get the clear-cut idea that how this particular sorting technique works. I request all the students just to write down this particular program into the journal for future use. Just pause the video and write down the program up to this closing bracket. Starting from this commented section to this closing bracket, write down the program by pausing the video. Then again resume the video and write down the program from this void main statement to this closing bracket. That means write down this selected number of lines. Again pause the video and write down this remaining selected line for the function called display. Fine. I think this is the sufficient time for writing the program. Just pause the video and note down the program in your journal and try to implement it in Turbo C if you have a computer. Even you can online perform this particular program through the online compilers also, which I have already instructed you into the semester number 1. So this was all about the sorting technique called insertion sort. One more thing we have to know about the insertion sort is its efficiency. So the efficiency of insertion sort algorithm and the number of comparison made to depend on the initial order of element in the collection for n elements, and n minus 1 passes. The efficiency differs in best, average and worst case scenario. In short, no doubt these are the heavy technical words. Let make it simple. One question comes in our mind: why all these types of sorting techniques are given? Ultimately, as they are sorting the numbers from smallest to highest or highest to smallest, then why there are different types of sorting techniques, like already we have done with bubble sort, insertion sort. Shortly we are going to discuss about various other techniques like selection sort, quick sort, bucket sort, merge sort, etc. as per the syllabus. Right? So what is the actual difference between all these sorting techniques? So the difference between all these sorting technique is the time and space complexity. If you remember, then we have discussed these two topics theoretically into the previous lecture, that is time complexity and space complexity. Here one more new word is introduced called parse. Parse means what? Actually these are the steps which has been taken by algorithm to sort the number. Say for example, for our number like 9, 4, 6, 2 and 1, for these 5 numbers, insertion sort takes for example 10 repetition. Comparative to this selection sort, suppose takes 6 repetitions, then the efficiency of selection sort is more higher than the insertion sort, and due to this every sorting techniques are bifurcated. No doubt bubble sort is easy to understand, easy to implement, not that much complex than insertion sort, but still insertion sort is more efficient than bubble sort, and selection sort even it is more better than the insertion sort. So these are the differences in between all the sorting techniques which we have to keep in our mind for learning all the different types of sorting techniques. So yet as per the syllabus we have completed with the two sorting techniques, that is bubble sort and selection sort. Next we'll go for quick sort. No doubt in today's lecture we are not going to start with quick sort, but I will just give you the brief idea about this quick sort technique. Quick sort technique is more faster than bubble and insertion sort. Even it takes very less number of repetitions for sorting the numbers. Whenever we see the theoretical and algorithm part of this quick sort, you will find that this particular sorting technique is more efficient. Before going ahead, I would like to take one example of a very famous search engine that is called as Google search. Say for example, over the Google search, whenever you write your requirement of searching the content, it displays the relevant content in one sequence. Randomly it will not generate the information onto the screen. Let me load the Google search engine first, then it would be easy to understand. Just type google.com over here, press enter. This particular website just contain one command button and one text box. Suppose here I am typing MVM and I am selecting the name of our college. Into the database of into the database of Google, starting with MVM keyword contains lot many information, but still it displays the name of our college with the website on a first position. That means it shorts the record and displays same onto the screen. So even in this particular website, one of the sorting technique works from this entire list. Which one? That you have to find. I have given you one task. Just find out which sorting technique is used by the Google search engine for displaying the sorted data onto the screen. So thank you very much students for today's lecture and have a nice day. In next lecture we'll go for quick sort.